In this video, we are going to see how to merge two sorted lists into another sorted list. So for this we are using array provided by C. So we are using C programming language for doing this. We have two arrays mentioned here. As you see, there is an array named A, which is having a size of 5, but the actual number of elements in the array is 4, 7, 12, and this is sorted in ascending order. And you have array B, which is having size of 8, but you have only 7 elements in this array. So n2 is the size of, or you can say number of elements present in the array is 7. n1 is number of elements present in the array is 3. But total it can hold maximum of 5. Here total it can hold maximum of 8. One is free. Now we are going to merge these two sorted array into another sorted array. So the resultant should also be sorted array, and the result is stored in array C. C size is 13, which is 8 plus 5. But number of elements in C will be equal to n1 plus n2, which is equal to 10. n1 is 3, 3 plus 7, 10. If we sort this and you get the full sorted array, if I merge these two sorted arrays, how it will be? First one it will be 10 minus 10, second it is 4, then 5, then 7, then 9, then 11, then 12, 14, 15, 21. So totally 10 elements will be here. Okay, 0 to 9, 10 elements, 3 here, 7 here. So if you merge, you see this one, this is sorted. Minus 10, 4, 5, 7, 9, 11. It's in ascending order. So this is separately sorted. This is separately sorted. So if you merge these two sorted arrays, I should again get a sorted array. So this is the one we need to do. Our objective is to merge two sorted arrays into a sorted array in another location. That location can be C. So if you want to write code for this, how can we write code for this? That's what. So before doing that, we'll just put a preliminary coding for this. We'll just declare arrays, everything. 4, 7, 12 is the data. So we have int A, name of the array, 5 sized array. We have 4, 7, 12. Okay. And we have one more array. Okay, so int B, I'll declare it again separately. Size is 8, number of elements present in the array is 7 elements, minus 10, 5, 9, 11, minus 10, 5, 9, 11, 14, 15, 21, 14, 15, and then 21. So this is array B. Okay, we'll declare array C of size 15, and we'll have n1, which is the total number of elements present in array A, that is 3, n2, the element present in array B is 3, 4, 5, 6, 7, totally 7 elements present. So as of now, these are all the variables we are using. We have just made the data ready in the code. Now we'll see how to do. Okay, so now if we check this one, it is sorted. This is also sorted. Okay, now what are we going to do? We are going to take one variable I, and that is going to point to A. We are going to take variable J, that is pointing to array B. So I points to array A starting 0th index, J points to 0th index of B. Okay, so initially it is like this, I is equal to J equal to 0. So what is exactly is I pointing to? Smallest element in array A. What is J pointing to? Smallest element in array B. So the meaning is all the other elements of this J, whatever it is pointing to, will be more than this. Whatever this I pointing to will be smallest in this A, the others are more than this. So if I combine these two, the competition is between minus 10 and 4, which will be the smallest. The combination of all these elements, the smallest can be between 4 or minus 10, because 4 is the smallest in list A, minus 10 is the smallest in list B. So if we combine these two, out of these two will only one will be the smallest. So which will be the smallest? So I just have to compare I and j. So I is pointing to 4, j is pointing to minus 10. Whichever is smaller, that will be the smallest in the merged sorted list. Is it or not? So 4 is the smallest in this list A, minus 10 is the smallest in list B. So I compare these two. Out of these two, which is the smaller one? That will be the smallest out of all the elements. Okay. So first I will compare this and this. Minus 10 is the smallest. Once whichever is smallest, you bring it to the array C. So minus 10 is brought here. Okay. Whichever is brought here, that has to be incremented. So j only brought here. Now j is incremented. J points to this place. I is still pointing here. Now what you have to imagine is, this is the logic. Okay. Compare the first element of both the lists. Whichever is smaller, bring it to the another list, or you can say append to the another list. And repeat, compare the first elements of both the sorted list. Whichever is smaller, bring it, or you can say append to the new list. Okay, so that will give the full sorted list once it is combined. Okay, now I incremented j because I moved. Okay, so this is moved. I just say MOV. This is moved to this one. Okay, that means j is pointing to the next element. We have incremented. So I is still pointing. So what you have to imagine is, now this is the new list. I'm putting this right, just change the color. So this is the new list now. This is the new list, and this is the list A. Okay, so list A is still whatever I pointing to, that is the start of the list. Whatever is j pointing to, that is the start of the list. Now you don't consider this as start. This is the start of the list. What j is pointing to, in this list 5 is the smallest. In this list, omitting minus 10, 5 is the smallest. In this list, whatever I points to, that's the smallest. Now again apply the same logic. Compare ij, whichever is smallest, bring it to the C, then move that pointer. Now I compare 4 and 5. Which is smaller? 4 is smaller. I just have to move it. 4 is moved here. Increment I. Whichever you moved, you have to move, increment that one only, not the other. So we have just increased this. This is moved. Okay. Now this is the normal one. This is not the part of the list now. That's the meaning. So you can say I is pointing to 7, j is pointing to 5. So this is smallest here, this is smallest here. Now we have to compare these two. So what I am comparing, 5 and 7. 5 is the smaller. I bring 5 here. So j is incremented. This element is moved. Okay. This element is moved to the list C. So now again you compare I and j. So this is a new list. New list starting from 9. Don't worry about these two. Whatever is moved, don't worry. So here 7 and 9. So 7 is smaller. So I moved 7 here. Then increment I. Okay, so this is moved. Okay, then increment I pointing here. Then 12 and 9 you have to compare. 9 is smaller. I bring 9 here. Increment j. So now j is pointing here. Okay. Now compare 11 and 12. 11 is smaller. Bring 11 here. Okay, so move. Then j, increment j. This is the logic. Once after moving, you have to increment that pointer. Now 12 and 14. 12 is smaller. I bring 12. You just increment I. Now I has went out of the array. So array is actually goes from 0 to 2. But now I is equal to n1. n1 is 3. So that means I is moved out. That means this is exhausted. There is no more to compare. So here j is still pointing to this 14. So 3 more elements are there. So obviously, since it is sorted, all these elements will be more than whatever that is currently here. Okay. So once it is exhausted, if anything is exhausted, okay, sometimes a bigger one might exhaust. Here don't think that since it is smaller it is exhausting. No. There are a number of elements. This may exhaust first before this. So for example, this is all starting from 44, 77 and 112. like this. 44, 77, 112 means all these will be brought here. J will be moved out of bounds. J will be exhausted. You got it? So if it is 44, 77, 112, I will be staying always here. J will be crossing this. That means it is exhausted. So now here I is exhausted. Once yes array is exhausted, if there is another array will be there. Okay, it will not be exhausted. Only one will be exhausted at a single point of time. Don't think that I and j will exhaust at the same time, because only one is moving. So if I is exhausted, j will be pointing to last element, or j can be pointing to any element. Okay, sometimes j can be pointing here, depends upon what type of data. Now in our case j is pointing to 14. So now what you have to do, just move all. Okay, no need to compare. Once something crosses, you just have to move all. 14 is here, then 15, then 21. Okay, so j is, this is moved. Once something reaches, don't need to compare, moved, j goes here, j plus plus. Okay, then move that. Okay, then j plus plus, then move that, then j plus plus. So now j crossed it. Now j crossed the boundary. That means j is equal to 7. Now you stop the whole algorithm. It's done. Okay. So this is the logic we are going to write in coding. So this is sorted. Okay. So let us try with starting stage. I hope you understood this logic. Then we will go to code now. I'm going to delete all these. Initially I and j points here. There are no elements here. Okay, there are no elements here, so if we code it, let's see how to code. Ij is equal to 0. That we have to do. I equal to 0 and j equal to 0 initially. Okay, so we have all these set now. So coloring, we'll just move to black colored. Okay. Now I and j points here. This is I, that's j. I is here, j is here. Now I have to compare I and j. Okay. So what is I pointing to? I points to A array, j points to B array. Okay. So we'll start like this. If A of I is pointing to A of I, okay, and j points to B array, B of j. Right. So if this is the case, we are comparing. What case? If I is bigger, what we should do? We have to whichever is smaller has to be moved. Okay. So if A is smaller, okay. So in this case, we have j is smaller. Okay. That means the whatever is in B is smaller. Minus 10 is smaller than 4. Okay. So else another one will be smaller. So in this case, if you see two cases we put. A of I, this is smaller. So I told you whichever is smaller has to be moved to C. Okay. So C has to be pointed by somebody. We didn't do anything for C. So let us have C is pointed by K. Okay. So K is equal to 0. So now C of K, initially whatever it is, initially the C of K, initially it is 0, okay, equal to, you just have to move whichever is smaller. So A of I, it is moved to C. Okay. Then what you have to do? You have to do plus plus I. You have to increment. Okay. So in the other case, in the else part where B is smaller, so same thing. I'm just copying and pasting here. What we have to do? C of K is equal to B of, it's B of J. Okay, B of J is smaller. Else parts, B of J is smaller. I copy B of J to CK. And which way I have to increment? J ought to increment. So this is a simple code. So this whole thing should be put up in a loop. Once it is there, then I am putting it in the loop. The whole thing I am putting it in the loop. Okay. This if else part I am putting it in the loop. So if I give some tab space, it will be good. Okay. we are building. So first I wrote the inner code and I am putting the whole thing in a loop. So once it happens, it goes again because I is one I or j is incremented. So in our case, you see which is incremented, j is incremented, it is moved. So minus 10 is here. Okay, so now j is incremented. So it goes again. It goes again. The loop goes again. So what is happening? You should understand. Again, we are checking. A of I is 0, 4. 4 is compared with 5. Which is smaller? 4 is less than. Okay, now C of k. You see this one? C of k. K is not incremented. Still, it is k is pointing to 0. So what we have to do? We have to increment that also. Once we would do I copying, you increment k also. Okay, now if I do k incrementation, earlier k will be pointing here. Okay, now when the loop goes, 4 is compared with 5. So 4 is less than 5, it enters the if body. So in ck, 4 is copied. Okay, then I plus plus, I is pointing here. Okay, then k also plus plus, k is moved here. K is moved here. Okay, now this is a simple code. Now we are going for exhaustive condition. Now which will come here? I is here, so 5 will be moved here. Okay, now j goes here. Okay, then 7 will be moved here. Okay, then I goes here. Then 9 will be moved here. J goes here. Then 11 will be moved here. J goes here. Then 12. Okay, 12 will be moved here. I goes here. So with the incrementation, whenever it is crossing, we have to check. Okay, so now I is crossing its boundary. Okay, so if I is equal to 3, that is equal to n1. Okay, that n1 all we have designed. So it's having 3 elements, everything. So we have to just put a code. If okay, this is for I is incrementations. So I incrementation is happening in this body. If I is equal to n1, that means it has crossed. If I crossed, what you have to do? If I cross, what you have to do? You have to just copy all the j elements till j crosses. You have to copy it in the resultant array. So now j is here. Wherever j is here, start copying elements one by one till j crosses its boundary. That means till j equal to n2. Okay. So if this is happening, now we have to put a loop while I have to copy j 14, then 15, then 21 till j goes here. That means 7 till j is equal to 7. Okay. So the loop checks till j is less than or equal to, or you can say less than n2. Okay, n2 is the size of the B array. So j is still less than n2, I have to copy. Okay, now j is somewhere here, we have to copy it here. C of k, we already done the k plus plus. Here itself we have done the k plus plus. So directly I can copy C of k equal to which one? J's. So that j is pointing to b's. Okay, b is j, c is in capital letters. Okay, so we are copying g here. Then j plus plus we have to do, or you can just creating j plus j, then plus k. Okay, now j is incremented. J is this one. 14 is copied here. Okay, 14 is copied here. J is incremented. Check whether j is less than n2. Yes, still less than n2. 7. This is 5 only. So I copied 15 here. Okay, so k incrementation is happening. Don't worry about that. So j is incremented. K is incremented. K will be here. Okay, then 21 will be copied here. Okay, then j is incremented. J points here. It will fail here. You got it? Is it j less than n2? No. J is equal to 7, not less than 7. So that means till that time you have to copy the other persons. Okay, other persons means this is in the A array. I is out of the bounds. When I reaches this place, then you copy the B array's elements into the resultant. So I is pointing to A array. When A array out of bounds happens, copy all the elements of B array, because there is no more comparison is needed. So the same thing we have to tweak it for the other else part also, because in else part which will go out of bounds, j may go out of bounds. Okay, when j goes out of bounds, that means when it is equal to n2. So if there is I which is still in inside this n1, that means still elements are there, then there is, we have to just copy all the elements into C. That means it is A's elements which is pointed by I, we have to copy. I is incremented, K is kept intact. So we just change all I's to J, and N1, N2 we have made a thing, right? So here when the J crosses N2, that means boundary cross for B array, we have to copy all the elements which is in the A array pending for comparison into C. That's what is happening. So go on copying elements from A array into C till I reaches the outer bound index. Okay, now that's it. So this code will be working properly. Now let us compile and see whether we have declared all the elements I, J, K, N1, N2. Yeah, I think we have declared all the elements. All the variables are declared properly. Now if we compile and let us see. For that, how to see, we will be printing. What is this bracket? Just see, it's a loop bracket. Okay, so once it finishes the loop, it has to come out. Where to come out? We put an infinite loop. You see, we have put an infinite loop. So where should we come out? Because it's once it reaches this place, once the loop is done, we break out. Okay, the same way, once we reach this place also, we have to break out. Okay, only one will say, in this case if you see, first only either I or either J will go out of bounds in a certain time, not both together. So if one goes out of the bounds, it will be reaching this area, for sure it will break out. Okay, either it, if I goes out of bounds, it will break out for sure. If J goes out of bounds, it will break out for sure in this place, because we are in this. So it is breaking out. If you put a break statement is inside this while. So we are coming out of this while because it is only a single loop. Okay, this break is not inside this while, it is in the outer while. So it is breaking out of the outer while, it will come out. Once it comes out, we can write a code to print it. So for I can use i's again, I less than n1 plus n2, I plus plus, this printf percentage d c of I. Okay, let us compile and see. See this one, we got a sorted array. You see, we have arrays 4, 7, 12, minus 10, 5, 9, 11, 14, 15, 21. Okay, so we have minus 10, this is smallest, then 4, then 5, then 7, then 9, then 11, then 12, then 14, then 15, 71. Okay, so all these are copied properly. So this is sorted array we got, that is stored in C. Okay, now what is the time complexity of this algorithm? The time complexity of this algorithm is n1 plus n2. Okay, so if I moves, j stops. Either only one moves. If I moves in this thing, when I is moving, j will be in one place. So j also travels through the whole thing, I also travels through the whole thing. But either only one will move at a certain point of time. If I is moving, j will be stopped. That means both traversals are happening. So it is n1 plus n2. So time complexity for this algorithm is big O of worst case is n1 plus n2 number of comparisons. If it is exactly interleaved, n1 plus n2 is the time complexity for this merging of two sorted lists together. Okay, I hope you understood. Thank you.